Hello girls and boys, welcome to Blackboard Techniques. In this class, we'll be solving the problem number 7 in exercise 1.5. If you check out the playlist in English, you'll be able to find out all the previous example problems and exercise problems with solutions. The video link is in the description. Do check it out. It would be helpful for you. Now we can see the question. Here, if seventh one, if f colon r tends to r and g colon r tends to r are defined by f of x equals x square x power 5 and g of x equals x power 4, then check if f comma g are 1 to 1 and f of g is 1 to 1. Here what is the question? The given data is f of x and g of x. What we need to find out whether this f and g is 1 to 1 function or and f of g is 1 to 1 or not. In one of previous videos, we had already discussed about one-on-one functions and not one-on-one functions. And R represents real numbers. Real numbers are starting. Real numbers includes positive numbers, negative numbers. So it will include minus, plus, 0 and everything. Now we are getting into the solution. For the solution, we need to write the given information first. What is given? F of x and g of x is given, right? So what is f of x? F of x equals x power 5. Then g of x equals x power 4. That is given in the question. Now we need to check whether this f and g, f of g is 1 to 1 or not. Here, what is 1 to 1? We need to know what is 1 to 1. 1 to 1 function. One to one function means if suppose we have two sets, 1, 2, 3, 3, 2, 1. So this we can say this is input, this is output. This is the relation. Relation means this 1 is input, this 3 is out. For input 1, 3 is the output. For input 2, 2 is the output. For input 3, 1 is an output. Here, all the inputs should have different outputs. We don't get same outputs for different inputs. Okay. I mean, for 1, we are getting 3 output as 3. And for 2, we are getting output as 2. In this set, for input 1, we have only one the output 3, right? We don't have any other outputs. Only 1, 3. For 2 also, we are getting only 1, 2. 3, we are getting only one output. Only one as the output. So we can say this is 1 to 1 function. 1 to 1 function. If suppose here also we are getting 2, output 2 for 3 means already we have one output as 2. Again we are getting 2 for input 3. So this is not 1 to 1 function. Not 1 to 1 function. this is all about one-to-one function. Actually, each and every input should have the different outputs. That should be unique. Okay, we don't get repeat output for different inputs. Okay, we should not get repeated output. That is very important. We are getting, we are here, we should consider this output only, this output. Okay, here we are getting two output two times. So this is not one-to-one function. If you're not getting two one more time, if you're getting one here, then it means every numbers are unique, every outputs are unique, so that it is one-to-one. Okay, for every inputs there should be a different output. That is one-to-one function. So here we have to check if G is one-to-one, or G is one-to-one or not, or f of G is one-to-one or not. F of G, composition of functions, right? You should know the concept of composition of function, then only you can solve this f of G. So now we have to check whether f is one-to-one or not. For that, already it's given f of x equals x power 5, right? So what I'm going to do is, I'm going to give different values for input. I'm starting from 0, 1, -1. Why? Because here we are having real numbers. R represents real number. We should include plus numbers, minus numbers, 0, anything. So I'm starting 1, -1, 2, -2, like that. Here, instead of x, we need to put 1, -1, anything, any numbers. So if it is 1 means here also we are getting 1 power 5, right? 1 power 5. 1 power 5 means what? 1 power 5 means answer is 1, right? So in this case we are getting, this is 1, this one is input, this one is output. So we are getting 1, 1. Then I'm giving -1. -1 the whole power 5 equals -1, right? If you are multiplying -1 into -1 into -1 into -1 into -1 5 times, we'll be getting -1 answer. So here what is the input, what is the output? Here -1 is input, -1 is output. And I'm checking one more value. You can check any values, any number of values. I'm checking one more, that is 2. If it is 2 means, if 2 power 5, what is 2 power 5? 2 into 2 into 2 into 5 times 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So I'm getting, what is input here? 2 is input, 32 is output. So I'm getting 2 and 32, right? Here I'm giving different inputs, 1, -1, 2. And also we are getting different outputs, 1, -1, 32. Look at this output only. Look at output only. We are getting different outputs. We are not getting same. If you are getting repeated outputs, we can say this is not one-to-one function. But here we are getting same. We are getting different unique values. So we can say, so that f is one-to-one. F is 1-to-1, right? So similarly we have to check g of x. What is g of x? in the question, g of x equals x power 4, right? So I'm starting from same thing. I'm going to put the values for x is 1, minus 1, 2, whatever we can put, but I'm going to apply 1 minus 1, 2. Now, first I am applying 1. So, 1 power 4 means 1. Here, what is input, what is output? 1 is input, again output is 1. And then I am giving minus 1. So, minus 1 power 4 means answer plus 1, right? Minus 1 into minus 1 into minus 1 into minus 1 plus plus. So we are getting plus 1. So the point is minus 1 comma 1, right? Here I am getting the output, same output again. In second step itself I am getting same output. So this output and this output is same. So what we can say, this g of g is not 1 to 1. So that g is not 1 to 1. Not 1 to 1. Then we need to check f of g. What is f of g? According to the concept of composition of functions, f of g is nothing but f of g of x. What is the expansion of f of g? F of g of x. This is the expansion. So here I should apply the value of x, g of x here. No. Without writing this, we can solve it easily. F of g of x. X value, we can directly apply x value over here. Yeah, if you are writing means no problem. We can get the answer. Okay. We can do the same step. F of g of x. Here I should apply the value of g of x. So what is g of x? X power 4, right? X power 4. F of, okay, x power 4. Then notice the next step. What should be the next step? Here f is given, so that in f function I am taking f of x formula. That is x power 5. In this formula I should apply the value x power 4 in place of x in this formula only. So I'm x power 5, right? Here x value is x power 4, so that I'm getting x power 4 the whole power 5. So what is the answer of x power 4 the whole power 5? We should multiply 4 with 5. 4 into 5, 20, right? So x power 20, we are getting x power 20. F of g is x power 20. Hereafter we should apply the values for x. Like real numbers means real numbers plus includes plus minus everything. So I'm giving 1 minus 1 2, the same thing what I have done before. Here for x I'm giving 1 first. 1 power 20 we will be getting plus 1, right? This is even number, so that I'm getting, definitely I will be getting plus. If it is odd number, I will get minus. So here what is input, what is output? 1 comma 1. Then if I am giving this is x equal 1, then I am giving x equals minus 1. Minus 1 means x power 20 minus 1 the whole power 20. So the answer would be minus 1 into minus 1 into minus 1 into minus 1 into 20 times. The answer would be plus value plus 1. I'll be getting plus 1, right? So here the point is, this is input, this is output. So I'm getting minus 1 comma 1. Here also same thing. I'm getting repeated output here and here. The output is 1, here also 1. So from this we can say f of g is not 1 to 1. Not 1 to 1. That's it. For f of g, what we have done? F of g, I am applying the composition of function concept. F of g, we should include the expansion first, f of g of x, and then should apply the value of g of x in f of x formula. In next step, in f of x formula, we should apply the value x power 4 in place of x, and we'll be getting this answer. And finally, we'll be getting x power 20. In this case, we should apply the different values, whatever value, plus or minus whatever. We'll be getting this kind of input and output. If you are getting different output, then we can say it is 1 to 1, but we are getting the same output again. So we should say this is not 1 to 1. This is all about problem number 7 in exercise 1.5. This much I had in this video. I hope this video helpful. If you found this video helpful, hit like button. For more updates, subscribe to the channel Blackboard Techniques. Share it with someone who might get benefit out of it. We'll see you in another video. Until then, Shiny signing off.